morning, everyone. I am your teacher in Mathematics 9, Evelyn V. Arafiles. Later, if you have queries, just call me at 0977-125-0441, or you can just approach me via Messenger. The concept of trigonometric ratios in previous lesson are essential in solving problems involving right triangles. Many real-life problems on right triangle can be anchored on this concept. Without knowledge on this concept, you would be in a dilemma learning the new lesson. Like word problems involving right triangle. So this is our lesson for today. Before we start, let us consider the most essential learning competency. Uses trigonometric ratios to solve real-life problems involving right triangles. Solving word problems involving right triangles is just like solving your own problem in life. Sometimes you can quickly solve the problem without any difficulty. However, there are times when you need to come up with a strategy to find the correct answer. So, let us consider the following steps in solving word problems involving right triangle. Number 1, read the problems carefully. Number 2, draw a figure or picture on the information provided by the problem. Number 3, label the parts of the triangle formed. Number 4, set up trigonometric ratios to be used in solving the unknown. Number 5, solve. Then number 6, answer the questions. So these are the suggested steps in solving word problems involving right triangle. So you should take note of these 6 steps because you will be using this as we go on in our discussion. So let's have an example. Sample number 1. The dimensions of a rectangle are 50 centimeters and 94 centimeters. Find the measure of the angle made by the diagonal and the shorter side. First step that we are going to do is we are going to illustrate the problem. After illustrating the problem, we are going now to represent the unknown and the given. Okay, so let angle theta be the measure of the angle formed by the diagonal and the shorter side. The next step, we are going now to determine the trigonometric ratio that we can use to find the problem or to solve the problem. Since the angle here is what we are solving for and the two sides are given, we can use tangent ratio, which is defined as the opposite side and the adjacent side. Then after that, we are going to substitute. The opposite side of angle theta is 94 centimeters. And the adjacent side, as you can see in the figure, it is 50 centimeters. Then, using your scientific calculator, you can solve now the angle. Okay, so it is 61.99 degrees. So this is now the measure of the angle made by the diagonal and the shorter side or the shorter leg of the triangle. Okay, let's have another one. So that is example number 2. One of the equal sides of an isosceles triangle is 21.1 centimeters and the vertex angle is 68 degrees. Find the length of the base of the triangle. Find the length of the base of the triangle. So that is the problem. First, we are going to illustrate. So as you can see now in the figure, the two sides here of the isosceles triangle are equal with a length of 20.1 centimeters. And the vertex angle is 68 degrees. Okay. So we can divide this into two congruent triangles so that it will be easier for you to find the base of the triangle. So we can divide this by drawing a perpendicular line from the vertex to the opposite side. So you can see now that this 68 degrees, it is divided into two congruent angles. We have 34 degrees. So we can separate it like this one. Okay, after that, we can represent the given or the unknown, I should say. The unknown is the length of the base of the triangle. So we use variable x to represent it. Okay. Then y is equal now to the length of the half of the base of the triangle. So this is now y, that is also y. Alright. So, looking at the figure or your illustration, the trigonometric ratio to be used is the sine ratio. Why? Sine ratio. So we know that sine is defined as the opposite side over the hypotenuse. So we have here opposite side of 34 degrees is y. And the hypotenuse is 20.1 centimeters. After that, we are going to substitute. So sine theta, you know that it is given, so you just copy 34 degrees. The opposite side is y. And the hypotenuse is 20.1. Okay? Using again your scientific calculator, you can find the value of sine 34 degrees. Then, you are going to multiply it to 20 0.1. So the process that you have applied here is cross multiplication. So you come up with 11.24. That is only the value of y. So since 2y is equal to x, thus x is equal now to 22.48. How did you get this one? We multiply 11.24 times 2. So we have 22.48. So the length of the base of this isosceles triangle is 22.48 centimeters. Okay. So that is example number 2. Next, let us have another one. So we have here a ladder 8 meters long leans against the wall of a building. If the foot of the ladder makes an angle of 68 degrees with the ground, how far is the base of the ladder from the wall? Okay. Again, we are going to illustrate or draw the figure. So we have here now the building. So we have a very nice building here. And we have here also the ladder, which is 8 meters long. So if the foot of the ladder makes an angle of 68 degrees with the ground, how far is the base of the ladder or the foot of the ladder from the wall? So that is what we are going to solve for. So in this case, we use again variable x to represent the distance of the base of the ladder and the wall. Okay, this wall of the building. After that, we have again to determine the trigonometric ratio of to be used. So, since you can see here now in the figure, the hypotenuse is given, which is 8 meters. And what we are going to solve for is this x. And this angle theta is 68 degrees. Therefore, the trigonometric ratio to be used is cosine. So, cosine is also defined as the adjacent side over the hypotenuse. So, using your scientific calculator, you can find the distance of the wall of the building to the base of the ladder. Okay, so you are going now to multiply cosine 68 degrees times 8. So we have 2.996, or you can round off this one to 3. So we have 3 meters. So that is now the distance of the wall of the building to the base of the ladder. Okay, so I hope you have learned something in this video lesson. So thank you and see you on the next video lesson.